Hello dear all, myself Dr. Pankaj Kabubra, Professor, School of Pharmacy, RK University Rajkot. I am going to discuss about the one of the most important topic in the medicinal chemistry is QSAR, Quantitative Structure Activity Relationships. QSAR is one of the important rational tools for the drug design. As we know that the drug design is a complex process. It takes too much time and too much cost. The time and cost is much higher as it take 15 year and more than $800 million, which is considerable as a high coster for the any one single drug development. Why the cost and time is too much? The reason behind that, there is a drug design pathway. Initially, as in the discovery, the scientist has to be synthesized around 10,000 different molecules. Each molecules take many days to synthesize. So it is the very time consuming step. In that, maybe 250 compound reach to the preclinical trial. Among that, maybe 5 compound reach to the clinical trial. That is also one of the costly stage because where human are involved. In that, last maybe one drug reach to the final FDA approval. So you can say that there is about the 15 year is to be taken. QSR is one of the method which help to decrease this timeline, decrease this cost, and make the drug discovery process is a faster. In this lecture, I am going to discuss why QSR is important, how to perform the QSR study, what are the different methods are used in the QSR, what are the different parameters that is used in the QSR, and application of QSR study. See, basically numbers of compound required for the synthesis in order to place 10 different group in a fourth position of benzene ring is about 10 raised to 4. Means suppose you have a lead. Lead means there is a compound having a somehow potential to producing the pharmacological action, but optimize is to be required. Optimization means we have to decrease the side effect and increase the desired effect. By the way, minimum 10 raised to 4 compounds is required, then after one compound reach to the final drug. To decreasing this task, QSR is play a vital role. How? That is very much as compared to the opinion poll. As we all very well know about the opinion poll is to be tested on selected numbers of populations, and based on the data, they predict the biggest picture. Look at this. That is a same thing as like a QSAR. The solution is synthesize a small numbers of compound, and from the data derive a rule to predict the biological activity of other compound instead of making a many molecules initially. First select a small numbers of compound, and from the data derive certain equation or certain rules to predict the biological activity of other compound which is not already synthesized. How is to be done? That is very easy. We can also perform the QSR study by MS Excel. So that I am going to discuss later. What is QSR? As in the definition, QSR are empirical relationship that use the molecular descriptors from the molecular structure to quantify a specific biological activity. We learn many mechanisms in the pharmacology, many mechanisms in the medicinal chemistry, how drug producing the pharmacological responses. So any pharmacological responses anyhow that is based on the certain molecular parameter. Either some molecular parameter is used in the binding study, some molecular parameter used in the pharmacokinetic. Anyhow, the molecular descriptors are useful. So QSR is a one of the relationship how the molecular descriptors are used to quantify a biological responses. And that is nothing but is a one mathematical model, means mathematical equation. We have learned the various mathematical equation, y is equal to mx plus c, or any equation where the biological activity is correlated with the physicochemical parameters. The results is the mathematical model that can be used to predict the activity or property of a new compound. So once we have a certain equation, then we can derive a parameter, we can derive or predict the biological activity of newer molecules. How is to be performed? QSR, I am going to demonstration of QSR by MLR. MLR means multiple linear regression analysis. That is one of the feature of MS Excel. We all know very well about the Excel. In that, MLR is one of the method. QSR can be done by the various method, but one of the simplest method is multiple linear regression analysis. What things that we are required for the performing a QSR study? So that is basically molecular structure that we are get from the lead molecules. From the lead molecules we get certain molecules, a certain set of the molecules having a particular structures. Using various software we can identify, we can calculated the physicochemical parameters. Physicochemical parameters mainly three: lipophilic, electronic and steric. Lipophilic parameter. Lipophilicity is that is important to drug lipid solubility and water solubility. Electronic parameter means charge on the molecules, and steric parameter which are the bulkiness of the molecules. These both parameter are important in the drug transportation and also in the drug binding study with the receptor. So basically three different types of the parameters are there: lipophilic, electronic and steric. Lipophilic parameters can be partition coefficient, pi substituent coefficient, Rm chromatographic parameter, solubility, elution time in HPLC. Electronics parameters are Hammett constant, ionization constant, field effect, resonance effect, spectroscopic chemical shift means delta value, sterics parameter means bulkier parameter. The property, molecular bulkier property can be determined by molecular weight. If molecular weight is more, then it will be considered as a bigger molecules. Molar refraction, polarizability, connectivity index, there are various parameters are there, but basically lipophilic, electronic and steric, three different types of the parameters are there. Second thing that we are require is biological activity. Whatever, suppose we are select at 20 different molecules, and this 20 molecules has to be evaluated on the animal study by any animal model that we are required. See, biological activity must be in quantitative term. Here, that not be in percentage or that not be in a qualitative, that must be in a quantitative term, means there is a some value. If value is there, then it to be used as a QSR study. There are total 6 steps to perform a QSR study. Step 1 is a select a set of the molecules which interacting with the same receptor with known activity. That type of molecules that we get from the lead identification. In the lead identification we can find the certain molecules which is actively binding to the receptor. Here from the my study, for the understanding, I am taking to improve the anti-adrenergic activity, and for that I have find a lead. There is a phenyl ethyl amine molecules. phenyl ethylamine molecules where the substitutions are there X and Y. My role or the outcome of this study is to be improvise the X and Y parameter. Which X and which Y parameter is important for the particular this study. So for first step, we have a set of the molecules which interacting with the same receptor with non-activity. Activity is to be performed on animal study by animal model. See, look at this first step. For X and Y, I have selected different hydrogen, fluorine, chlorine, bromine, methyl, or etc. etc. X and Y both are the different substituent. Now, first thing is that which substituent is to be taken? Can we take as randomly? Because we have to select for the my study. I have select about 22 molecules, compound number 1 to compound number 22, and for that there are different substituent. The substituent is a diversify. As I have already tell that this QSAR is exactly relevant to the uh, opinion poll. So in opinion poll, how the population is going to select? Suppose the opinion poll is generated from the Gujarat election, then they are taking a population or people from the Gujarat. But which type of people? Some of the older people, some of the younger people, some of the newer voter, male, female. They can again diversify the peoples from the occupation. They they sit living in the city, living in the village. That means diversification is required. But here, which substituents are to be select? So that is also diversify. But we don't have a much more idea about the diversifying substitution. So how we can going to select the diversifying substitution? That is to be selection by the crack plot. Crack plot is help us to identify the or selection of the substituents. See, there are four pole in crack pole. There are four pole. First pole, sigma. Sigma is Hem at a constant. Pi is a lipophilic constant. Sigma is a electronic constant. So electronic and lipophilic both are positive. The groups are functional groups are fluorine, nitro, CF3. Here plus sigma, negative pi means electronic parameters are positive, lipophilic parameters are negative. Groups are COOH, sulfonamide, amide, both negative. NH2OH, electronic is negative, lipophilic is positive, like alkyl. So what to do? Can we select all these three? It is better. Can we take all these three from this group? It is better. No, we have to select each group from the four different pole. That means we selected diversify functional group which having a diversified data which give a better results. But from the my study, I have select the parameter that is a predatory parameter, so it may not be as like this. So that is about the first step, selection set of the molecules which interacting with the same receptor. Now step 2. Step 2 means calculate features. Here we are going to calculate physicochemical parameters, 2D or 3D property of the molecules by software. Various software are available like ChemDraw, ISIDraw, Sibyl, Dragon, VLife, and they are widely used to derive various physicochemical parameters. We are going to demonstration how the physicochemical parameter is going to derive by using a ChemDraw. You can open a ChemDraw, draw a structure. How to draw the structure? The structure drawing, you can use the tools. Here there are tools are there. you can use a benzene ring, 6-member, 5-member, or any of the particular rings are required. That is here. Everything is there. Once you can use the ChemDraw, that is very used to software. So based on that, just I am going to draw the structure. There is one benzene ring, then a alkyl chain, ethyl amine means alkyl chain, and there is having a nitrogen. And first you have to make a framework, that's called as a framework, and then put the atom. Here bromine, B must be capital, and R. Here nitrogen, and suppose you put NH itself, they show something that is wrong, so you need to put only N. That is inbuilt character of software. Once you draw the structure, then first thing, select the structures. You can select the structure by using this arrow. Then again goes into the structure, check the structure. Is there any error? No error found. No error found. If any error is there, then it show the error or it show the red part. Again click on the view. Here there are various options are there. You have to click on the show chemical property window. Once you click on the show chemical property window, it will show you a different chemical property. Look at this: boiling point, melting point, critical temperature, critical pressure, critical volume, Gibbs energy, log P, MR, Henry's law, heat of atom, C log P, CMR. This all are calculated physicochemical parameter. Means here suppose boiling point is 588.96 K. That means suppose you prepare this molecules and measure the boiling point by any practical method, it may be near about to this, because this parameter is calculated by based on the chemical feature. There are log P value is 3.76. Log P value is 3.76. Means log P value is 3.76. Means you are going to perform a partition coefficient experiment, you will get the value near about to this. Once you change any group, suppose I am going to change here to look at this chlorine, then again I am going to select this molecules. The log P value is 3.83. if I am going to select this, then log P value is 3.76. for this, that is 3.83. all parameters are going to change. Once you change a single group, then the chemical parameter is changed. So by based on this, you can derive a physicochemical parameter. You just put different group on X and Y, you will get the different chemical property. That is 2D chemical property. You can also derive 3D chemical property. Various different coefficients are also available, that can be also derived by basis on that. That is very simple. First you draw the structure, select the structure, clean up the structure by using this mode, check the structure, and then goes into the view show chemical property window. Okay, next is a we have derived a chemical property. See here, from my case I have derived pi, sigma and es, these three parameter. for my 22 different molecules. Now for my data set, I have a 22 molecules, 3 physicochemical parameter. Pi is a pi substituent constant, lipophilic parameter. Sigma is a Hammett constant, electronic parameter. Es is a steric constant, that is a steric parameter. Now step number 3. Step number 3 is divide this set to two subgroup. One is a training, another one is a testing. One is a training and another is a testing. Training set and testing set. How is to be do? Again, we have moved to taking the understanding from the opinion poll. Once any opinion poll population is to be selected, then that make certain peoples to have a training, certain people as a test. Based on the training, they generated the response, and whatever response they are got, that checked by the testing. Those peoples are remaining. Again, at last they will take the opinion from that. If the predicted opinion and the generated opinion both is same, then it's called as a validation of this study. So here we have to prepare one training set and one test set. Training set means that are used to generate the model. Test set is means that is used to validate this model. But how? We have 22 compound. Look at this, we have a 22 compound. So among that, which compound is to be taken as a test, which compound is to be taken as a testing? Generally 20% compound is to be taken as a testing, 80% compound is to be taken in training set. But which compound is to be testing, which compound is to be taken in the training, that is to be by the diversity. Look at this, we have another third number of parameter. Another important thing is log 1 upon C, that means biological activity of these molecules. I have a 22 molecules, 1 to 22, and these are the biological activity of all these molecules. Now I am going to select training set and test set. As per the 20%, I have a total 22 molecules, so 4 molecules is to be taken as a test set. Which 4 molecules can I take? This 4, first 4. Can I take this 4? Can I take this 4? No. We have to take one molecules which is having a lower biological activity, one molecules that is from the higher biological activity, one or two molecules from the mid. So by based on that, I can select these 4 molecules. Number 2, which is having a considerable lower biological activity. Number 7, which is having a considerable middle biological activity. 13, which is considerable somehow higher biological activity. And 20 number, which near about to maximum biological activity among this generated data. So I have a select number 2, 7, 13 and 20, 4 molecules as a test set, while rest of the 18 molecules as a training set. That is step number 3. First step, that is selection of set of the molecules. Second step, generated physicochemical parameter. Third step, that is about the convert generated training and test data set. Now step 4, build a model. Here there is a role of actual QSAR models that is used to find the relationship between the activity and property. Now we have a activity in for my data set. Log 1 upon C is biological activity, and these are the pi, sigma and Es. These three are pi, sigma and Es. These three are physicochemical parameter. So now it's time to generate the relationship. How much pi parameter is affected to biological activity, how much sigma parameter is affected to biological activity, how much ES parameter is affected to biological activity. For that, we are going to study multiple linear regression analysis, MLR. Multiple, that is a Excel sheet where I have taken the number 1, 3, 4. So I have taken the training set, 18 molecules. Look at this, there are total count is 18. So 18 molecules are taken. The test set molecules is omitted from this data sheet. There are pi, sigma and ES3 parameter, and these are the biological activity. Now to perform a regression, first you have to go in data. Once you click on the data, some of you maybe get data analysis at here, some of you may not. If you don't have a data analysis in your dialog box, first you have to add. How is to be add? Just click on this dialog box, right click, customize the ribbon, then goes in add-ins. Here in my, there is analysis toolpack in active application. In your case, there is analysis toolpack in inactive application. So if it is inactive application, you have to click on the analysis toolpack, click on the go, and OK. It will be installed offline. It doesn't require internet resources, because uh, as usually Excel give the most usable feature. Some of the feature are used by the only limited person, so that will not give a inbuilt feature. So once you find data analysis is here, click on the data analysis, find regression. In that there are T test, F test, Z test, ANOVA test, all tests are there because there are analytical tools. You have to find the regression, click on OK. Now you have to put Y and X range. Y means there is a biological activity for our cases. X means physicochemical parameter. So there is click on this arrow, selection mode. You just click the entire biological activity for the 18 different molecules. Then input X range. X range is a physicochemical parameter. For the my case, I have a 3 physicochemical parameter, pi, E and ES and sigma. I have going to select all these 3. Okay. Selection of Y and X. Y is a biological activity. X is a physicochemical parameters. Just click on OK. Within a fraction of second, you will get a new Excel sheet where you will get summary output of your results. Here in summary output, first you have to find the R square value. R square value is a correlation coefficient. Statistically, it is considerable as a relationship between the X to Y factor. If it is 0.99, it will be considered as a very good. If it is lower, 0.1, 0.2, 0.3, it is not good relationship. Another parameter is standard error. Here standard error is 0.17, that is considerable lower. Observation is 18, means we have a 18 parameter. F value, here you need to find the F table value and you need to compare F table value with this. But for important things for us, that is about the coefficient. intercept, x variable 1, x variable 2, x variable 3, and the coefficients are these three. So it means we have a biology. X variable 1 is a x variable 1 for our study. X variable 1 is a pi. X variable 2 is a sigma. X variable 3 is a steric ES. Okay. From that we have to make the equation. So from this study we can get the equation log 1 upon C is equal to 7.62. 7.62 is intercept plus 1.31. 1.31 is the coefficient of pi. So 1.31 into pi. Second, for that minus 1.7. Coefficient for the sigma is minus 1.7. So we are going to put minus 1.7 into sigma. Then third parameter ES plus 0.164 into ES. That is our equation. Log 1 upon C is equal to 7.62. That is the intercept. Then coefficient 1, 1.31. That is the coefficient for the pi. So we are going to put pi at here. Then coefficient 2 minus 1.7 minus 1.7 into that is coefficient for the sigma. Then plus 0.164 into ES. That is our first equation. We can also find the equations for the two parameter. Here for understanding we are taking only three parameter, but when you are going to actual study you have a many parameter, 100 parameter, 200 parameter, like this. So among that which parameter is good, which parameter is not related to biological activity, that is to be identified. So for that one by one you have to take all this parameter. Again I am going to repeat this task for the two parameter. So repeat this task for the two parameter. First click on the data analysis tool pack, select regression, click on OK, select Y range. What is Y? Y is a biological activity. So again we are going to select biological activity. X is a physicochemical parameter. So we are going to select the physicochemical parameter. For the my study, for this time I am going to select first two parameter, pi and sigma. Okay, just click on OK. Within a fraction of second you will get the summary output, where again you have to find the R square. Here R square is 0.88. For this three parameter we have R square is a, for this three parameter we have R square is a 0.91. For the two parameter we have R square is 0.88. It may be higher, it may be lower, but that is important. We have to just note it here. Standard error 0.186. Again intercept x variable 1, x variable 2. That is again important for us. So for that we are going to make the equation like this. Log 1 upon C is a biological activity for our case is equal to intercept is 7.786 plus coefficient for the x variable 1 is a 1.24. So plus 1.24. That is coefficient for the x variable 1. X variable 1 is what? Is a pi. So into pi. Then x variable 2. X variable 2 is what? Minus 1.74. So we are just going to put it here. Minus 1.74. X variable 2 is what? X variable 2 is a sigma. So again we are going to write it sigma into sigma. Okay, that is our equation. Log 1 upon c is equal to 7.786 plus 1.24 into pi minus 1.7 into sigma. That is for the two parameter. Here I have select pi and sigma. You can select sigma and es, pi and es, or any of them. But upon that, you will get numbers of equation. You will get numbers of equation by using this. So you can put like this. Here model number 1, that is my first equation. Whatever we get from the regression sheet is this. That is second equation. What we get from the regression sheet is this. Both observation is 18. R square for the first 0.91, second for 0.889. Standard error here less, here higher, and that is F value. So suppose there is a, for the understanding I have taken only 2, but when you are going to perform actual study it may be more than 100 equation. So among that, which equation is better? Which equation is better? That is to be find by helping of a R square value, standard error, and F. R square value should be higher, standard error should be lower. R square value should be higher. For my cases, model number 1, R square value is higher. Model number 2, R square value is lower. Standard error here for this cases it is lower. This cases that is higher. F value, that you have to check F value with the table value. F value is appropriate to numbers of observation, that you have to go for the statistical table. But basically R square give the idea about which equation is better. There are many other techniques to identify the better equation, but simply the correlation coefficient R square is one of the parameter which is used to identify a best model. So upon that, my first model is best model. Among these two, the first model is to be considered as a best model. Now step number 5. Again we have a taken as a 4 compound as a testing set. Now there is a role of testing set. We have generated the equation. And based on the equation we get the find the best model. Test set. Role of test set is to be validate the generated model. Role of test set is to be validate the generated model. Validation is required. Without validation you cannot predict the biological activity for further. You must have to open this into the Excel. Here, look at this. Number 2, 7, 13 and 20. These 4 are test compound. I have already calculated the physicochemical parameter pi, sigma and es. That is observed value, means animal study will get the value 7.52, 8.4, 8.89 and 9.3. Now from the equation, my equation number 1 is a best equation. From the equation I have to find or predict the biological activity of this compound. So here I have put the equation 7.62 plus 1.31 into pi minus 1.7 into sigma plus 0.164 into ES. That is nothing but just I have put the pi, sigma and ES value into the equation. They will give the predicted value. Here predicted value is 7.32. For the second, 8.49, third that is 8.71, fourth is 9.62. Now just correlate this. Second number compound observe activity means animal study activity is 7.52, and from the my model I will get the activity is 7.32, very much near about this. For all 7.4, 7.49, 8.8, 8.7, 9.3, 9.6. Means in the cases, suppose I have a in the compound number 2 observed value is 7.52, it will not get the 9.62 in predicted value. So residual difference of this to this to this to this to this is not much higher. We can also find R square correlation, R square CV or other parameter which is used to evaluate the residual amount of that. But simply by based on that we can find that whatever value we observe means we get from the animal study, the same value or near about the value that will predicted by our equation. Here the value is predicted by formula number 1. So that means look at this. For 4 molecules we have done this study and we get sufficient reliable results. That means whatever model we generated, this model is validated, that can be further used for the prediction. It is okay. So testing set is used for the validation of generated model. Now last step, using this model predict a compound which having a maximum biological activity. Now we have a model, we have equation log 1 upon c is equal to 1.31 into pi minus 1.7 into sigma plus 0.164 into ES plus 0.762 is a intercept. So how to predict the biological activity or how to predict a molecules which functional groups are useful for this? So primary, first you have to identify the positive contribution and negative contribution. See in this 3 parameter pi, sigma and ES. Pi and ES both are positive contributor because there are they coefficient is a positive, while for the sigma it is the negative contribution. Means suppose you are going to increase the sigma value, that will decreasing the log 1 upon c. Our aim is to increasing this, but suppose you are going to sigma parameter, that will multiply with the 1.7 and is the negatively, so biological activity is going to decreases. So here in this case pi and ES are positive contributor while sigma is a negative contributor. Second thing, here 1.31, here 1.7, here 0.164. So once you compare the coefficient, the 0.164 is exactly 10 times lower than this. 0.164 is around 10 times lower than this. That means 1.31 and 1.7 pi and sigma give the higher contribution while ES give the lower contribution. Means suppose you are changing a parameter 1 unit in this and 1 unit in this, then ES give the 10 times less effect. So we have to concentrated only higher contributed parameter. Higher contributed parameter is pi and sigma. Pi and sigma. So in first case, we have to find the positive and negative contribution. Second thing, we have to find the higher and lower contribution. From that, last step is from the optimum biological activity, what we have to do, we have to find the functional group which is having a good pi parameter and less sigma parameter. Means that's having a higher pi value but lower sigma value. That we can find from the counter plot. So that means you don't have to synthesize 10 raised to 4 molecules. You don't goes to synthesize 10,000 compound. Within a small number of data set, 20 to 100 data set, you will generate such type of equation. By using this equation, you can predict the biological activity of possible molecules which having a maximum biological activity. You get 5 or 10 molecules. You can prepare these molecules in laboratory, go for the animal study by animal model, and match the